Welcome back to Geometry. It's me, Mrs. Belyakov. Today's lesson, lesson 92, says quadrilaterals on a coordinate plane. The purpose of this lesson is to identify the quadrilaterals on a coordinate plane using the slopes of their sides. For example here, let's see. In example number 1, it says, is ABCD a parallelogram? It is asking me if it is a parallelogram. For me to identify if it is or it isn't, I need to remember what a parallelogram is. It's a four-sided figure that has two pairs of parallel sides. So what we're trying to prove is that AB is parallel to DC and that AD is parallel to BC. If that's true, then this is a parallelogram. For that, let's recall a few concepts. For example, let's recall that parallel lines have the same slope. That means that AB and DC would have the same slope if they were parallel, right? And also let's recall the formula for the slope, which equals y2 minus y1 over x2 minus x1. That means we need point number 1 and point number 2. Because, for example, this means the value of y in point number 2, and the value of y in point number 1, and so on. As I said previously, we need to prove that this and this is parallel, and that are parallel as well. So let's calculate the four slopes of the side segment to compare them. The first two I'm going to compare are going to be AB and DC. The coordinates of A are 1, 4. A equals 1, 4. The coordinates of B 5, 7. 5, 7. Let's see DC. The coordinates of D is 2, 2, and the coordinates of C is 6, 5. 2, 2, and 6, 5. I'm going to work with these two segments first. Segment AB, segment DC. I'm going to calculate their slopes first. So let's say the formula, it's up here, y2 minus y1, x2 minus x1. These are point number 1 and point number 2. So the slope equals y2, which is 7, minus y1, which is 4. All of that over x2, which is 5, minus x1, which is 1. Let's simplify that fraction. The slope equals 7 minus 4 is 3. 5 minus 1, it's 4. We're not going to put it into decimal. We're going to leave it like that as a fraction. Let's work with the slope of the second segment. It says slope equals, we have the formula here, y2 minus y1, all of that over x2 minus x1. The slope equals 5 minus 2 is 3, all of that over 6 minus 2 is 4. So as you can notice, the slope here is 3 over 4 and here is also 3 over 4, meaning that AB and DC are parallel. Now we need to prove that these two segments are parallel in order for us to conclude that this is a parallelogram. Let's continue. We have segment AD and segment BC. Segment AD and segment BC. Let's compare those now. Slope equals y2 minus y1 over x2 minus x1. 2 minus 4 is negative 2. 2 minus 1 is 1. If we simplify that, it's negative 2. Let's see here. Slope equals y2, which is 5, minus y1, which is 7. All of that over 6 minus x1, which is 5. 5 minus 7, negative 2. 6 minus 5 is 1. Simplified is negative 2. So as you can notice, this slope matches this slope. So that means that this side and that side are parallel. So what can we answer to example number 1? That yes, it is a parallelogram. But I can conclude that after I made all my checks, right? I wanted to share something else with you. Let's see. Thanks, sorry guys. Thanks God, because our lives and His did not remain parallel. They intersected the day we said yes to Jesus. Bless you guys. See you in next lesson.